Students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a very important concept related to climate change and global warming, which is called as carbon capture and storage. So most of time, carbon capture and storage is portrayed as a very effective solution in tackling the climate change related issues. So the subject of our today's discussion is going to be how effective carbon capture and storage can be and whether it is a viable solution, practical solution and implementable solution for tackling climate change in longer term or not. And if it is a good solution, what are the challenges and concerns that people have related to the CCS? So first of all, to give you the brief context of this particular topic, CCS is portrayed by many scientists and engineers across the world as a key tool to stop climate change. Obviously, it has its cost, but for decades, people are continuously working on this method. However, it has not yielded desired result as of now. Experts believe that carbon capture and storage is sorely needed to cut the pollution in those sectors where other clean technologies are much farther behind. There are cases where capturing carbon makes a lot of sense. However, at the same time, we have to be aware that we need to push all the other options to avoid the CO2 emission in the first place, because many times it can also cause a kind of chain reaction where industries, factories and other enterprises can believe that since we already are capture carbon, let us not focus upon the controlling the emission. So that is also a wrong approach. So let us try to understand what is carbon capture and storage. So obviously, clear from the name itself, CCS refers to a method by which industries try to trap the carbon dioxide and carbon based molecules which is released in the atmosphere and then store it below the earth's surface where it remains preserved over a long period of time. Now, one other term that is used in this context is called as CDR, which refers to carbon dioxide removal. Now, both these terms are different from each other. For example, in case of CDR, carbon is sucked out of the atmosphere. However, some technologies that is used in CCS and CDR can obviously overlap. But if we understand the major difference between CDR and CCS, it is such that in the case of CDR, it is basically used to bring down the level of carbon dioxide that is already present in the atmosphere, where the net effect of this method is in cooling of the planet Earth. On the other hand, CCS refers to the fossil fuel plants and factories that are producing carbon dioxide in during the process. So the method is basically aimed at preventing the CO2 gases from getting out in the first place. So that is how the CDR CCS differ. For example, again to repeat, CDR is capturing the carbon dioxide that is already present in the atmosphere. CCS focuses upon the prevention of the release of CO2 in the atmosphere at the first place. So if we talk about CCS, which is today's topic of discussion, basically it involves three steps. The first step is obviously the capturing the CO2 for storage purposes. Second stage is transportation of these captured carbon dioxide gases in liquefied stage mostly, and last is the storage in we can say aquifer. For example, if you look at this diagram, we can see in the first stage, for example, if we take a look at power station, take an example of power station. Obviously, CO2 is one of the major byproduct of this power station because which is produced due to the burning of natural gas. So once CO2 is basically captured from this power plant, they are separated from the other gases, then they are converted into liquefied form because it is much more easier to transport these gases in liquefied form. Once they are converted into liquefied form and separated from other gases, later on they are stored under an aquifer, which in this case can be below the seabed. For example, North Sea in UK, most of the CO2 captured by United Kingdom is stored in the aquifer that is present below the North Sea. Similarly, one of the example we can take is when the carbon dioxide is being removed, it is actually stored underground in the form of in the places where we have natural saline aquifer or where you have depleted oil or gas reservoir, and largely to make sure that CO2 do not is not released if there are some sort of tectonic activity or some sort of disturbances. The scientists make sure that it is stored at least at a depth of 1.5 kilometers or more, and also there are presence of impermeable rocks that keep the CO2 underground continuously. Once these gases are stored inside the ground, they become stabilized within the porous rock because it reacts with the rock particles, the elementary and the minerals that are present in the rock, and react with the rocks to form natural compound with the surrounding brines and minerals. Many times the CO2 react with the calcium rocks present in the earth, and then they form a stable form of calcium carbonate and limestone, which is a solidified form of CO2, which is more stable than liquid or gaseous form. So the question comes that if it is so good method, is it practical to be implemented on a larger scale? So the answer is that for decades, actually, engineers have captured carbon from concentrated stream of gases, pushed it into the tanks, scrubbed it clean, and used it in industries or stored it underground. Now here we have two interesting case studies. For example, if you take bioethanol plants, in the bioethanol plants, we have the pure gas stream. And these pure gas streams are much more easier for the purpose of CCS. And in this case, more than 95% of carbon emission have already been captured. Similarly, if we talk about, on the other hand, if we talk about the factories and power plants which releases huge amount of CO2, they have dirtier gas streams. And when there is a dirtier gas stream, CCS projects have repeatedly failed. Basically, if we do not want to use the term fail, we can use the term it has overpromised and underdelivered. So the problem does not lie with the pure gas stream. The problem lies in the practical implementation of this method when the dirtier gas stream comes into picture. So now when the dirtier gas streams comes into picture, we have again two different examples. One, if you look at the test facilities, where the couple of dozen of test facilities has been developed all across the world, the test facilities have been able to capture more than 90% of the emission. On the other hand, if we try to implement the same method on the commercial projects, on larger projects, there are several and numerous problems that the scientists and engineer have faced, which make it impossible to implement practically. However, experts still believe the expert, they see the failure of CCS more as an economic problem rather than a technical problem, because they cite the one of the major reasons why these commercial projects are not taking off successfully is lack of R&D investment, that lack of research and development investment which is required to make any new technology practically implementable. And that is where the willpower of the government and politicians comes into picture. Now, the storage of captured carbon, as we have discussed, can be stored in saline aquifers, depleted oil and gas reservoirs. But the what would we have to make sure about is at least it is lying that more than 1.62 miles or at least 1 kilometer under the ground. In this case, we have two very good examples. One is Zero Carbon Humber project in United Kingdom, where a saline aquifer named Endurance has been set up under the southern part of North Sea, around 90 kilometers from the offshore. Similarly, in United States of America, we have a project that is called as Citronelle project in the Alabama state of USA, where multiple large-scale carbon capture sites has been developed. In the case of US as well, the saline reservoir injection site is about 1.8 miles or 2.9 kilometers deep. If you look at the CCS, which actually began in the United States of America, the successful operation of CCS began somewhere in the year 1972, and since then, the CCS projects have been able to capture more than 200 million tons of CO2 underground in a stable form. However, as we have discussed, any project is not free from controversy, and so is the case of the CCS. So if you look at controversy around CCS or why critics do not want to focus upon CCS as a noble way of fighting climate change, is because they believe that rather than focusing upon capturing of CO2 in the later stages, we should put more weight on the societal shift. Societal shift here refer to changing the approach of the society to tackle any problem. For example, rather than focusing upon the what we can say as adaptation, the CCS is kind of adaptation method. We should focus upon cutting the energy demand in the first place so that the overall need of release of CO2 will be minimized, rather than placing the faith in shaky technologies and their implementation. Second, as we have discussed, one of the major problems with CCS is it is ineffective and impractical, as at least on the commercial scale. And third, critics argue that over focusing upon the CCS might lead to companies, enterprises fighting to burn fossil fuel as much as they can, as much as they want, because by involving or engaging in CCS, they'll feel that they have been given a social license to operate in a carbon heavy environment. And using carbon capture is something that should not be seen as a climate solution, but basically to enhance the extraction. A big part of this is what fossil fuel companies call enhanced oil recovery, because many times they pump the carbon dioxide underground to push out more oil from the drying wells. Now, one related term that we have to understand about is what we call as CCUS, that is carbon capture and utilization. So here in this, the major difference is rather than capturing the carbon and storing it, we actually utilize this captured carbon in various methods. For example, in various industrial processes by converting into, say, for example, plastics, concretes, or biofuel. So example, we have capturing of carbon dioxide that is released from power plant, for example, transported via pipeline or ships, and then it is utilized in mineral, biological, chemical processes, and finally it can be stored back. But overall, if you look at the conclusion of today's discussion, what we can say is to make any technology, whether it is CCS, CCUS, or other related technologies, and to make it cheaper and work better, analysts believe that government need to tax carbon. When the government start to tax carbon, it will be much more easier to approve CCS projects and then help set up the infrastructure around it. They are less sure about subsidizing the technology itself because that has also been touted as one solution. However, many experts argue that this is not a viable solution. There needs to be subsidy for green steel and green cement because that's really what's going to push the people who can accelerate the development of carbon capture and storage. So that is all about today's topic of discussion. I hope you understood the concept behind today's video. If you like the video, please hit the like button, share it with your aspirants, as well as subscribe to our channel for more such content. Thank you very much.